Good Friday morning, backyard naturalists and participants in the Brew City Birding Festival and everyone else who is tuning in. My name is Tim. I work at the Urban Ecology Center in Milwaukee, Wisconsin, and welcome to a special presentation of the Backyard Naturalist. Sometimes we talk about the stars and planets aligning in conjunction, and today is an extra special conjunction of both the Backyard Naturalist, which happens every Friday morning at 9 a.m. rain or shine, and the Brew City Birding Festival, which happens in some form without fail the week starting the second Saturday of May on Global Migratory Bird Day. So welcome everyone. Today's episode is not limited to birds alone, although birds are a big part of the story. We're going to be looking into the processes and patterns of animal migration of all animals, including birds. Migration is dangerous, migration is costly, migration is risky, yet millions of animals are migrating all the time, and migration is fascinating, it's awe-inspiring, and it's puzzling. And so I'm excited this morning to begin to peel away a few of the layers of this mystery in episode 34 of season 3 of the Backyard Naturalist, Lost in Migration. And as I mentioned, this is a hybrid talk of the Brew City Birding Festival and the Backyard Naturalist. And so this is my chance to thank all of the people who support this community and the Urban Ecology Center in many ways, by being members of the Urban Ecology Center. Thank you. By being subscribers to the Backyard Naturalist series. Thank you. And by being a frequent flyer pass holder for the Brew City Birding Festival. Thank you. And I'm honored to be spending time with you today. And I'm humbled by the many ways you all support the Urban Ecology Center and our mission of Gesundheit, connecting people in cities to nature and to each other. The festival ends tomorrow, but bird migration continues, and so does the fun. So through Sunday, with the Wisconsin Society for Ornithology's first ever Big Birding Bash. This is a statewide event to see how many birds we in Wisconsin here can find collectively over a 2-day period. In Milwaukee, there will be events tomorrow, Saturday, in Seminary Woods with Metro Audubon, and Lake Park with the Lake Park Friends Warbler Walk, and at Estabrook Park with the Sunday Birders making a rare Saturday appearance, and along the Milwaukee River and in Three Bridges Park with the Urban Ecology Center for the final 2 events of the Brew City Birding Festival, Beaks and Boats and Birds and Beverages. So to sum up, Brew City Birding Festival, Big Birding Bash, Beaks, Boats, Birds, Beverages. There's also a meetup planned at the Estabrook Beer Garden at 11 a.m. to share sightings and stories. And so you can join in one of the planned events or just bird on your own anywhere in Wisconsin either day. So if you bird this weekend and you bird on eBird, you can share your list with WSOBBB to add your sightings. It's a really cool new event from a great organization. Side note, I've had the absolute and unique pleasure of hearing a gray-cheeked thrush sing outside my home office window this morning. A bird I often see during migration, but hardly ever hear. Gray-cheeked thrushes are one of the Catharis thrushes that have one of the most haunting, ethereal, hollow sounds as they duet with themselves. And you can check that out in, I think, some of the lectures from last year's Brew City Birding Festival, which are online, to see how birds can duet with themselves. So migration, we're here to talk about migration. There's a lot to say. So we'll start with the definition. At its root, it's pretty simple. Essentially, migration can be thought of as a large-scale movement of an animal species from one place to another. If you look into this yourself in different types of dictionaries, biological or the standard Webster's, you'll see that some definitions get a little more specific, maybe adding seasonality or completeness. And you'll even find some definitions that conflict with each other in those minutiae. But for all intents and purposes, migration is the large-scale movement of an animal species. Now, these are the walking palms of Central and South America, called the walking palm because the tree itself actually is able to move by sending out shoots that become rooted on one side, and then they lose the shoots on the other side, and the trunk of the tree actually moves, albeit very slowly, depending on local conditions. So if a gap opens up in the canopy, this tree actually can move itself toward the sun. And you can imagine in your mind this group of palm trees marching across the plain like ants. But this is not a migration, although it's fun to think of it as migration, because even though the trees are moving, if we go back to the definition, migration is limited to animals. So sorry, walking palm, really cool, but not migrating. And here's another animal that's not technically migrating. This is a mountain lion, could be the Milwaukee lion from a few years ago, that's moving across a great range to find a new home. And every once in a while, you'll hear about a mountain lion that's tagged in Wyoming and then ends up, up in Massachusetts. But these animals are not technically migrating, they're dispersing, and it's also not a large group. So different process, but when you hear about these stories, whether it's a mountain lion or a badger, it's usually a young male that's wandering around looking for a new home, so not migration. But we're not going to focus all on not migrations. We're going to focus on the animals that are migrating, and there are many, many, many animals that exhibit some form of migration, and we'll meet a few of them over the next half hour. And it's important to start with the point that migration is a very dangerous process. Mortality percentages almost across the board increase with migration. A lot of bad things can happen to a migrating animal. They're leaving the comfort of their home, the comfort of their routine. They become targets for predators, for hunters, for traps, for cars on roads, for towers, windows. They're more susceptible to parasites. So there's a lot of things that can be detrimental to a migrant, to migration. So then the question is, why do animals put themselves in danger and expend all of that energy to move great distances? And the answers are complex and poorly understood. We're only going to get about halfway through the story, which necessitates a part 2. But scientists and other knowledge seekers have identified 3 main reasons why we think animals migrate. And the primary reason for migration has to do with food and water, essentially staying alive. And food and water are absolutely necessary for survival. So most animals that migrate do so either because they're trying to find a place where the food and water is so they can stay alive, or interestingly, they'll migrate away from an area, not because there's not food and water there, but because they don't want to completely exhaust that food source from that area. So if they didn't migrate away, they might eliminate that food source completely. Then that would be detrimental to their long-term survival because they and their offspring couldn't come back. So at the risk of anthropomorphizing, animal species seem to be much more intentional in keeping their food supply long-term than us humans that are often driven by the short-term gains. So whether it's intentional or not, you'll often see animals leaving a place that still has food. And it's not really important to think that they know why they're doing something. The end result is that millions of years of evolution has resulted in animals being pretty good at not exhausting their food and water supply, otherwise they'd go extinct. So that's a lesson that we humans, at least modern humans, better learn collectively pretty quickly. Most migrations can be explained by food supply, but then there's other processes that also play a major role in explaining why animals will go through the lengths to migrate. And one of these is breeding and mating. It's kind of lumped together. So this would be animals that are moving to a spot that is more conducive or safer for mating or for giving birth, or sometimes both. And both of these processes will put animals at risk. And so it makes sense for animals, again, to not only stay alive, but to make sure future generations are alive, to put themselves at risk to move to a place that is safer to give birth. And we'll look at a couple examples of that, including the 2 that are here. And then the third kind of major force that we think causes animals to migrate is climate and weather. And that pattern is usually that a place becomes too cold, not always too cold, too extreme in other ways, but usually a place becomes too cold for an animal to survive. based on their adaptations. So we here in Wisconsin and Massachusetts are very familiar with birds and bats flying south for the winter. And you could also frame this migration as being driven by food, because winter in Wisconsin often means a loss of an animal's food source. But even if the food were here, many of these animals aren't adapted to our harsh winters and they'd perish. So it's also safe to look at birds flying south through the lens of climate and weather as easily as you could say driven by a lack of food. So we'll hit on all these reasons in the coming stories and kind of look at the influence of these major driving forces for migration. So again, food and water, breeding and migration, and weather and climate. And they're not mutually exclusive. They're oftentimes working together. So it makes it more complicated, but also makes it more fun. And we can use that to look at now the types of animal migrations. So again, we like to categorize it, put things in boxes and nice groups. And so the first category we'll look at is called complete migration. And so in complete migration, it's fairly straightforward. All of the members of that given species migrate. So a fun example of a complete migrant is the Arctic tern. All Arctic terns migrate. They travel about as far as you can on the planet Earth, from the Arctic to the Antarctic and back again every single year, a round trip migration of more than 18,000 miles. Although we're learning now that this might not be the longest bird migration, as we're as the science advances and we're able to tag birds, their sheer waters might rival this. But regardless, that's a long way. And just looking at this bird, you can see or start to understand some of the classic adaptations of long distance migrants. So that long pointy wings, the long pointy wings is really good for efficiency in lift and thrust. And they can sleep while flying by turning off half their brains at a time. They will coordinate their wing flaps with breathing and oxygen exchange that makes it extremely efficient. There's all kind of chemical and mechanical energy efficiency systems that are in place. It's almost as if it was designed by an engineer, resulting in very little effort to move through the air. Some species are not complete migrants, but they're categorized as partial migrants. And some of you have probably heard me tell the story of how still to this day, I will get calls from concerned residents in January who are worried because their robin is still in their backyard and it didn't migrate south in the winter with all of its friends. And they want to know if they should rescue it. But robins are considered partial migrants, which means not all robins migrate every year. So some individuals do migrate regularly every year, but others will stay in the same place year round, even here in frigid Wisconsin, which causes these concerned neighbors to give me a call. And so it's a mix of genetics and learned behavior. And it's really a product of genetic diversity that all of these options are in place for a particular species. And then another example of a partial migrant is the wonderfully named three-spined stickleback fish. Within this species, some individuals will spend their entire lives in freshwater areas. Some individuals in the same species will spend their entire lives in estuaries, which are brackish. And then some individuals will migrate seasonally between the two areas. So animals that exhibit partial migration often have larger ranges that can support some individuals staying put and others migrating. And partial migration is actually thought to be the most common form of migration in animals in general. And it's likely the evolutionary precursor to complete migration. A third category is called differential migration. And in this scenario, all of the members migrate, possibly, but not necessarily at the same time or even for the same distance. And this is pretty common in birds. So all the examples here are birds. So herring gulls, older individuals will migrate shorter distances than younger individuals. In springtime, we know about the male red-winged blackbirds arriving first, and then the females a couple of weeks later. In American kestrels, males spend more time at the breeding grounds than females, and they migrate a shorter distance. And then again, not all of these categories are mutually exclusive, like complete and partial is, because you can have differential partial migrants and like the gull, or you can have differential complete migrants like the red-winged blackbird. The dark-eyed junco is also a differential migrant. Older and younger individuals and males and females all have different migration patterns, and that gives a lot for people that want to know, research scientists and others. Gives them a lot to study, because why you have the competing forces of the dangers of migration. There's benefits and drawbacks to migrating farther. There's risks and benefits to staying closer to where you are. And so they'll look at it from a male and female perspective and an older and younger perspective, and put in game theory and try to come up with all these, great reasons why you have this complexity. Another category of migration is called eruptive migration. And in this case, members of a species may go several years without migrating at all, but then all of a sudden they do migrate, and maybe all of a sudden they do migrate for several years in a row. And in the years that they do migrate, they may migrate just a short distance, or they may migrate a long distance. So lots of unknowns, and maybe one of the more complex systems. In this case, migration is often triggered by a weather event, like a particularly cold spell that may push individuals out of an area. It may be triggered by, probably more often, by food. And so if food becomes scarce in an area, you can't stick around, but if food is plentiful, you can. So blue jays are normally considered non-migrators, but if their winter food source of acorns becomes scarce, they will migrate until they can find food. And snowy owls famously undergo cyclical eruptive migrations because their food source undergoes cyclical patterns. So when the lemmings that aren't throwing themselves off cliffs are plentiful, there's no reason for the snowy owls to go anywhere because they have enough to support them, and migration is dangerous. But then when the lemming populations crash, which happens, every few years usually, then some snowy owls need to head farther south to find enough food. It's usually the younger, less experienced owls that undertake the dangers of migration. But basically there aren't enough of the lemmings in the north to support all of the owls, so some of them have to leave. Wildebeest are often considered eruptive migrants in a slightly different way. In this case, they're just following the food and the water, and sometimes they'll even follow rain clouds in anticipation of rain. So they need the food and the water. Weather acts unpredictably, and so the migration patterns of the wildebeest also act unpredictably, even if there is a regularity to seasons. Where they're specifically going might change. So all of these animals will go where the conditions are right, and the conditions might be right where they are, or it might be right just down the road a little bit, or they might have to travel quite a bit farther away to get the right conditions. A fifth type of migration that sometimes is a little depressing to think about is called removal migration. And that refers to migrations where animals just leave an area and they don't come back. There's no intention of coming back to the habitat that they're leaving. This often happens if their habitat becomes unlivable. So that can be because of climate change. It can be because of deforestation. It can be, maybe the swampland they rely on becomes drained to become farmland. But essentially, in removal migration, they leave an area for good because they really can't come back. And it's not always caused by human intervention. So this group of short-horned grasshoppers, you may know it as a locust swarm, that is considered a form of removal migration because they end up making their own habitat inhospitable because they do overconsume, and then they need to migrate great distances in search of habitat with sufficient food. So that's natural. It's exacerbated likely by humans, but this is a natural form of removal migration. And there's a little bit of a blurry line between removal migration and dispersal. dispersal, the line is mainly drawn by whether the ouster is caused by environmental conditions or social conditions. But then again, dispersal usually is more on an individual animal basis rather than a group of animals. So whether it's, again, environmental or social helps determine that. Migration isn't always across lands, north, south, east, and west. Sometimes it's up and down. That can be either in the ocean, or it can be in mountains. And so animals that live in mountain ranges can migrate seasonally up and down in what are called altitudinal migrations, often for the same reasons as the other migrants that we've been talking about, because higher altitudes essentially behave similarly to the extreme northern or extreme southern latitudes. So examples of altitudinal migrations are found in billy goats or mountain goats, spotted owls, and the resplendent quetzal. So that's the major groups of migrants. So we've got the kind of major causes as to why we think animals migrate, and then we have the types of migration. So now we'll move on to visiting some of the more fun and famous animal migrant stories. And we'll start with one of, I don't know, maybe the most famous or most iconic former backyard naturalist featured critter, the monarch. And we've featured monarchs quite a bit in the past. Monarch migration is already in several of the past episodes, including Monarch NATO. So I'm not going to spend a lot of time here, but the feature that makes the monarch migration almost too bizarre to be true is that it's generational. So monarchs leave the north, leave Wisconsin, Massachusetts in September, and return in May. In fact, I just saw my first monarch this week, and I think I heard others say they saw their first monarch last week. But oddly, it's not one individual that makes the journey. The monarchs we see now are actually the grandkids of the monarchs that left last fall. So essentially, one individual starts the migration, travels all the way to Mexico, overwinters, begins the return trip, but they don't make it all the way back. They might make it to Texas, where they lay eggs and die. And then through some strange combination of genetics and, I don't know, black magic or some kind of magic, the egg that hatches in Texas then continues their parents' journey northward. But they're not even going to make it all the way back here. They might make it to Kansas or Illinois, and they'll lay their eggs there and die. And then finally, it's the grandkids or sometimes the great grandkids that will finish that journey, making it back here up north. And some generations of monarchs then don't migrate at all. They spend their whole lives as cheeseheads up here in the Badger State in the summer. So we'll take our first and really only video break. So I've got a series of 3 short videos that look at very different but also very similar migrations, starting with the monarchs. And again, there's a lot of great videos out there, but I found a new one that's from a series where the filmers, you may have heard this, the filmers will dress up their cameras as spies, whether it's like elephant dung or a floating plant. And in this case, they disguised the camera in kind of a fun way to capture one of the absolute wonders of the natural world, which is the congregation of butterflies in winter in Mexico.
In the heart of this grove, 500 million monarch butterflies lie sleeping. They have traveled from as far as Canada to escape the cold northern winter. How they return to this exact spot is a mystery. Like the butterflies, hummingbirds feed on nectar, so our spy isn't seen as a threat. While resting, they cluster together to conserve precious warmth. But as the winter ends, the sun warms their fragile wings. Once they reach a critical 50 degrees, they start to fly. As the day warms, the forest comes to life. Spy hummingbird won't harm these delicate butterflies. Its moving parts are shielded to keep them safe. butterflies can even safely land on its wings. It begins to capture something quite extraordinary. What starts as a trickle soon becomes a stream. Then grows into a cascade. A spectacle that has rarely been filmed. And our spy is harmlessly in the very heart of it. Beauty also lies in the detail.
So that's an example of insects in North America who fly vast distances to essentially stay alive because an adult monarch could not survive a Wisconsin winter. And this is an example, I think most of us are familiar with this monarch migration. But it's cool to know there's a parallel event happening halfway across the world that looks and feels similar to this monarch spectacle, but involves an entirely different group of animals in Southern Africa. So let's go to that one.
Just beyond the meadow, 10 million straw-colored fruit bats now live in the swamp, all squeezed into half a square mile. This is one of the largest known gatherings of fruit bats in the world. And in terms of numbers, it's the largest mammal migration on Earth. This one special patch of moist evergreen forest provides the bats with a comfortable home during the heat of the day. They jostle for roost space, using a hooked claw on their wingtip to grip and climb. Gingery bodies and pointed faces give the bats the nickname flying foxes. Each bat is about 8 inches long, but has a wingspan of 2.5 feet. The wings are formed from a membrane of skin, crisscrossed with a network of hair-thin muscles which control stiffness and shape. Unlike insectivorous bats, fruit bats don't use echolocation, but rely on vision instead. At night, eyeshine reveals large eyes. Sight and smell guide them to their fruity feast. And these woodlands are full of their favorite food, waterberries. Each bat eats 5 pounds of fruit every night, twice its own body weight. By the time they leave in a month, over 1 billion fruits will have been devoured, and the trees will have been stripped bare. These ravenous winged visitors are some competition. But the bats are more of a bonus than a burden. They're responsible for 60% of all seed dispersal here, replanting the forest and ensuring there's always enough to go round.
So I don't know. I think it's really cool that there's so many similarities between the monarchs in Mexico and the fruit bats in Zambia. So then we'll move halfway around the world again, not from west to east, but from south to north, to get a glimpse of migrants that travel even greater distances, but don't have the advantage of being able to fly.
Northern Canada's wild frontier. Here, nature stages one of her greatest dramas. Every year, 3 million caribou migrate across the Arctic tundra. The immensity of the herd can only be properly appreciated from the air. Some herds travel over 2,000 miles a year in search of fresh pastures. This is the longest overland migration made by any animal. They're constantly on the move. Newborn calves have to be up and running the day they're born. But the vast herds do not travel alone.
Dun, dun, dun. So caribou have the longest overland migration of any animal. So as my superstar favorite narrator mentioned, so annually 3 million caribou journey across the Arctic tundra to find fresh grazing areas, 2,000 miles a year. Sometimes as the video clip was alluding to, they will bring along a resident wolf pack for part of that migration. And so you kind of have this case where both caribou and wolves are driven to migrate for food, but then the wolves at some point are like, wow, you guys aren't stopping. I'm hungry and all, but 2,000 miles is crazy. So we'll sit tight here and eat something else. So from the air to the land, now we can move to the sea. And one of the most, iconic ocean creatures, the baleen whales, the gray whales, the humpback whales. And what's interesting about this group is that for a lot of the species, they're divided into northern and southern populations. And they'll take advantage of different areas of the globe at different times. So in a couple months, the UEC is traveling with a group down to Costa Rica with the hopes of seeing humpback whales. And the whales that we will hopefully see will have just finished their long migration from the south, from Antarctica. So why were they down in Antarctica in the first place? During our winter, the Antarctic waters are in their summer and they're just teeming with krill, and the whales are there to eat all those krill. So remember, food is a driving force often of migration, but like most mammals, whales will give birth on an annual cycle, and a baby whale doesn't really have the blubber to survive in those frigid Antarctic waters. So they need to move to warmer waters like Hawaii and Costa Rica to give birth. So we'll be looking for the southern population when we go there in August. But if we were to go there in February, the animals that we would see in August would be back down in the Antarctic waters. So we would be seeing the northern population there in February. And the northern population spends their summers up in the Arctic waters, like Alaska. So conceptually, it's a little it's easier to understand than it is, at least for me, to put into words, but hopefully this illustration helps. But essentially both populations migrate north and south at the same time, so they never run into each other. In our summer here in the Northern Hemisphere, the southern population of humpbacks are up in the tropical areas giving birth. And then the northern populations are way up in the Arctic waters like Alaska, taking advantage of all the krill. But then in our winter in February, these northern populations are down in the tropics giving birth, and the southern populations are down in the Antarctic waters fattening up. So the two populations are mirroring each other, but they're always a half a world apart. And it's not just the temperature of the water that's the primary, it is a driver likely, but it's also a lot safer for these whales to give birth in the tropical coastal areas, because if you think of their major predators, great white sharks and orcas, they're mostly found in the colder waters. So it's both the food driven and that breeding safety that are the major drivers of this huge migration. And this happens in more than one species. If we stay with the theme of swimming migrations, we're switching now to a different group of animals, the fish. I think one of the best stories is told by salmon. So the Chinook salmon begin their life hatching from eggs laid in freshwater in inland rivers of the Pacific Northwest. And then they stay in those fresh waters for about a year, where they can grow in the kind of relative safety of these inland nurseries. But then they migrate to live most of their life as a salmon in the open ocean, and they're there for several years before they return to that same exact inland freshwater stream spot where they were born to give birth themselves. Because if it worked for them, it'll work for their young, hopefully. And all of the complexities aside, just the fact that these fish that live and breathe water can move from a hypotonic freshwater environment to a hypertonic salty environment is just astounding. And their adaptations, both the physical and the chemical adaptations, are pretty drastic. And the same species, the same individual of salmon looks very different when it's in the inland waters from when it's out in the open waters. So that's a lot of effort to undergo in a lifetime. And then, why don't they just stay in the open waters? Similar to the baby whales, there's just a lot of major predators, and a baby salmon wouldn't have much of a chance in the open ocean with all the predators. But they do survive very well in these inland nurseries. But then these inland streams aren't large enough to support a large population of adult salmon, so they have to head to the open ocean for food for most of their lives. So driven by food to the open oceans, driven by breeding conditions back to the inland waters. And unfortunately, the human story gets in here too. Salmon populations have taken a hit from dams on the rivers, and that prevent the access or inhibit the access between the two environments, which has had a huge negative effect on salmon populations. And it's why so many are working to advocate for the removal of the dams, or at the very least, to build fish ladders so that the salmon and other fish can migrate. And then for this final story, we'll head back to the air for a Wisconsin-based story. The whooping crane is the tallest bird in North America, but their populations took a huge crash as a result of habitat destruction. A crash that nearly wiped out the entire species. In fact, it did wipe out the entire eastern population. There was a small pocket of animals in Texas of less than 20 individuals. So that was all that was left of wild whooping cranes. And Robin, you can correct my story, because I know you know the story a lot more than I do. But they were about as on the brink as you can get. But what some humans took away, other humans tried to replenish. And so a major operation was underway to try to conserve whooping cranes in general, and then also, to build back their numbers. And that alone is a huge undertaking. But then part of the plan was to reintroduce the whooping cranes that were lost from the eastern United States. So scientists reared a group groups of chicks from captive populations wearing crane costumes so they wouldn't imprint on humans. And I don't know. I don't know whether to be in awe of these pictures or to laugh or to be scared, because it kind of looks like a low budget crane horror film. But this eastern population, again, was a migratory one. And then a key part of crane migration is that young birds learn the migration routes from their parents, but there were no parents to teach the young how to migrate or where to migrate. So in a now well-known effort, the human scientists led these young cranes on the 1,200-mile journey from Wisconsin to Florida in ultralight aircraft, with the pilot still wearing the crane costumes. And then the young cranes learn the migration route and are now able to teach their offspring the route. And currently there are over 800 wild whooping cranes spread over different areas. Some are migratory, some are not. The migratory population in the east that was reestablished is still only at about 80 birds, which is a lot or a little, depending on how you look at it. So they're still facing many threats. We're not out of the woods yet, but things are starting to look up. There were a lot of drawbacks, a lot of setbacks, but in one of the recent field trips for the Brew City Birding Festival, participants found a wild whooping crane in Horicon Marsh. So many animals migrate, sometimes in spectacular fashion. And then I quickly realized that, like ants, the story of migration is probably best told over 2 episodes. So this morning we kind of looked at why animals migrate, and we looked at the different types of migration and some of the individual species stories. And then in the next episode down the road, we'll look into the hows and how they migrate, how they know when to migrate, how they know where to go, and then also continue that theme of it's really complex and there's a lot we don't know about how animals migrate, but it's still fun to look into the stories. So part 2, as a shout out to Jenny and Joe, we'll look at one of my favorite migration stories, the herds of wildebeest sweeping majestically across the plains of Torquay. But today we'll end our episode with a moment of Zen video that looks at migration from a similar species up in Yellowstone.
The greater Yellowstone ecosystem has some of the most incredible wildlife migrations in the world. We have the 9 major elk migrations radiating out of the national parks and wilderness areas every year. The famous 120-mile pronghorn migration from the Upper Green River Basin into Grand Teton National Park, and the newly discovered 150-mile Red Desert to Hoback mule deer migration.
Yellowstone is this incredible icon for protected areas globally, because it was the first national park.
Migrations connect working lands to forest lands to parklands.
Political boundaries mean nothing to nature. It's a permeable boundary, and they just move back and forth as their biology dictates.
I think these migrations might be the greatest wonder of the greater Yellowstone ecosystem that people haven't seen until now.
Within 2.5 seconds, she was on me. I swung at her with a shovel.
All right. So thank you for joining me in this look at animal migration. I look forward to part 2 in the future, and I hope you do too. So we'll see you next week for another episode of Backyard Naturalist as Riverside Park branch manager Chris Steinkamp takes us back into the world of honeybees. So enjoy the weekend, everybody. And I will
Thank
stop.
you.